This red LED has two prongs on it, two wires. The longer one goes to the positive side and the shorter one to the negative side for current to flow. The longer positive leg goes into +5 and the shorter negative leg I'm just putting into this slot here. Now I'll take the ground connection. Well, don't try this at home. I'm covering my eyes with a safety shield now, and I'll connect that to the low side and we'll see what happens. Flashes a little bit and it looks like it's let the smoke out. That LED is never going to work again. You don't want to have this turn black and let the smoke out and destroy the LED. You need to put a current limiting resistor. Let's try again. This time I'm going to take this red LED, I'm going to put the positive into the +5 section and the negative into here just like I did before. But instead of connecting it directly to ground and letting all that current flow, I'll use a resistor here. So it's connected here to here to here to these resistors, but right now these resistors aren't connected through to anything, so nothing's completing the circuit. But let's see what happens if we complete the circuit. First, I'll complete the circuit with this resistor here, and we see a nice bright indication on the red LED. This resistor has a green, blue, brown band on it. Green means 5, blue means 6, brown means 10. That's a 560 ohm resistor. Now this other resistor here is currently not connected to anything, so it's not having any influence on the circuit. But it's brown, black, and orange. Brown being 1, black being 0, and orange being 3 more zeros. So that's a 10,000 ohm resistor. So if we connect the LED through that one, less current will flow. And sure enough, the LED lights, but it lights really dimly. If we connect an LED from 5 volts with a current limiting resistor in place down to ground, then the voltage drop from here to here will be whatever the voltage, forward voltage of the LED is. So if it's, for instance, 2.7 volts, then this will be 2.3 volts. And the amount of current that flows in the circuit will depend on the resistance that we have here. So Ohm's law will apply and we'll be able to figure out how much current flows. So V equals IR, or I equals V over R. The smaller the resistance, the more current is going to flow. So if we made that resistance 0, like I did in the last instance, then the current would go to infinity, at least by this relationship. But in fact, what will happen is the more current that goes through here, the diode starts heating and burning up, and eventually it just breaks. Sometimes with a flash, sometimes with a bang. So you need this resistance in here to provide you with a current limit, and you need to figure out for your assignment what that resistance should be.